All right, so once you move the 21 squared to the other side, we get a squared equals 135. And then we got to take the square root of both sides. Okay. You always want to check to see if there's a square that goes into these numbers. On the previous page, we only had square root of 5, and that can't be simplified. There's no square that goes into 5. When numbers get bigger, we might have something that goes in there, like 4, 9, 16, 25, or so on. So 9 is the square that goes into 135. It goes in there 15 times. So we take the square root of 9, gets out 3 square root of 15. So that is the missing side right here now, 3 square root of 15. Okay. All right, so now we can find all the other trig functions. Sine theta, I actually have all the answers over here. Let's just check it out. So sine theta, opposite over hypotenuse, but then reduce the fraction, right? 3/24 can be reduced to 1/8. So here's the 1/8 on that. So square root of 15 over 8 is the answer. Okay, flip that over for cosecant, and then rationalize. Okay. Cosine and secant we did right at the beginning, so those are taken care of. We only have tangent, cotangent lefts. So tangent would be opposites over adjacents. Math is very similar, just a different fraction reduced. Now it's 1/7. Flip it over for cotangent. Okay. Okay, last thing I would do today is just kind of introduce these special right triangles, go over this relationship, and we'll wrap it up with 5, 6, and 7 here. Okay. All right, so these special right triangles always have this relationship between the legs that we can count on. As long as the angle is 30 degrees and 60 degrees, or we call it the 30, 60, 90 triangle, it's always going to have this relationship of the small leg to the hypotenuse. It's going to be double. So sometimes it might not be 1. Let's just say this is 5. Well, this has to be 10 then. It's going to be twice the short leg. Okay, so we call this L. This is 2L. Every time with the 30, 60, 90 relationship. The long leg is related to the small leg by L times square root of 3. I want to write those in there. Okay. Now, we like to keep things simple, so we usually start with a small leg of 1 when appropriate. Like I said, if this was like a 5, then we'd say this is 5 times the square root of 3. All right, with a 45, 45, 90 triangle, or sometimes called an isosceles right triangle, because these legs are equal, so that's why it's called isosceles. Then this is the relationship. Whatever these legs are, we should call them just L for legs. And then this is always going to be L times the square root of 2. All right, so in this section, for the most part, you're just getting comfortable with these, but we're going to use them so often that you're just going to have these sides memorized. So find the sine of 30 degrees. I got to find the appropriate angle. There it is. So what's the sine? Opposite over hypotenuse. You just got to ignore the adjacent side. Got to follow the definition, right? So 1 over 2, don't be thrown off by that. It's that easy when the triangle is given to you. Okay? Pause and try 6 and 7. Should only take you about a minute for each one, and then we'll check our answers. All right, so 60 degrees. We've got to find the angle. Here it is. This is the angle we're using. Remember, cosine theta is A over H. So secant is going to be the reciprocal of that. So secant theta is H over A. So what is the hypotenuse in this triangle? It's 2. We can just use these numbers that we have over the adjacent side. So if I'm looking at this angle, the adjacent side has to be right here. Don't use this. This is opposite. This is adjacent to 60. So 2 is the answer. Tan 45. Now I'm using this triangle here. Doesn't matter which one because it's isosceles. So this is going to be opposite over adjacent. So it's going to be 1 over 1. Okay. All right, we'll stop there for today. Just a heads up on the directions on 23 and 24. I'm going to have you try these. It's expected that you can go ahead and use these sketches for these. They just didn't show them, so I'd use your notes. And it says, all right, tangent at 30 degrees. What's 30 degrees in radians? So use your skills from the last sections to figure out what that is if you don't have it memorized. And then it says, what is the answer, the function value? So tangent at 30, we'd be looking at this triangle to figure that out. All right, so they don't have the sketches here for you on those two, but that's what you're going to use to figure out 23 and 24, okay?